Welcome back, ladies and gentlemen. Today we're going to tackle 10.2 arcs. On the screen, you'll see the exit question for the day. Today is a lot of vocab, so you can either do a pause the video and do a screenshot or transfer this information to your note guide in some way or fashion. But here are your vocab words for the day. Last time we defined a circle as the collection of all points equidistant from a center. I'm going to repeat that one vocab word. You'll see why in a moment. A central angle, we're going to be talking about arcs, which are a portion of a circle. So a central angle is an angle with a vertex at the center of a circle. So we talk about central angle ACB. An arc is simply a piece of a circle, and it is defined by the measure of its central angle. A minor arc is an arc whose central angle is less than 180 degrees. A major arc is an arc whose angle is more than 180 degrees, or between 180 and 360, because if you have more than a circle, then obviously it's no longer an arc, it's kind of a spiral sort of thing. I don't even know what you would call that. The reason I repeated circle is because we have a lot of notation to talk about today. So you need to be able to use these symbols properly. When you're talking about a circle, you can use this symbol to denote a circle. When you're talking about a central angle, it's just like talking about an angle that we've always talked about. I would suggest using 3 pieces, though you could probably get away with referring this to central angle C in this case, because there's no other angles emanating from that single point. However, the arcs are a little bit different. You've got a little bit of notation to remember. That little symbol means arc. And if you're describing a minor arc, please only use 2 letters. If you are describing a major arc, it is most common, though not necessarily required, to use 3 letters. So if there's a point along your way, grab it and name your 2 endpoints. So you have to name the 2 endpoints. And if you've got a third point that's labeled on the drawing, use it. If you don't, and it's rare that you don't, you can get away with calling this major arc AB, but we want some distinction between minor arc AB and major arc AB. So if you include that third letter as a middle point or a point along the way, that helps distinguish whether you're talking about a major arc or a minor arc without actually having to say the word minor or major. In addition to these notation symbols, we can also talk about the measure of an arc. The measure of an arc is measured in degrees, and it is the same measurement as the central angle. So we can say the measure of ACB equals 55. We can also say the measure of AB is 55, or the measure of arc AB is 55. We can also do the same thing with the measure of a major arc. Next, we have a congruency statement collection. So in order for 2 circles to be congruent, they must have the same radius. I believe that's an if and only if statement, regardless of that symbol right there. In order for 2 arcs to be congruent, now this gets tricky. Remember, the arcs are the actual portion of the circle, the little piece of a hoop that needs to be exactly identical in shape. And in order for that to happen, you have to have not just the fact that they have the same central angle, but they also have to be contained within a circle that has the same radius. So in order for 2 arcs to be absolutely perfectly congruent, they need to have the same central angle, and they have to be in circles that have the same radius. Either 2 circles with the same radius or the same circle that is obviously then congruent to itself. And lastly, the measure of arcs can be the same, but that doesn't necessarily mean that the arcs are congruent, but we can use an equals sign to describe the number of degrees here that you would get and the number of degrees there that you would get. Simply having the measure of the arcs equal to each other does not force congruency. It only forces that the central angles are the same. They could be in 2 different circles that have extremely different radii. So you could have a central angle being the same in a radius with a radius of 2, or the central angle being the same with a radius of 2,000. And they would obviously be very different shaped arcs, but they would still have the same central angle. Next, we have two more vocab words. Semicircle is simply an arc that has endpoints on a diameter, or in other words, the central angle is 180 degrees. And adjacent arcs, which are basically the same thing as adjacent angles. Instead of sharing a common side, they share a common endpoint. Postulate 23, arc addition postulate. This basically says the exact same thing as the segment addition postulate and the angle addition postulate, that the sum of a large piece, or the measurement of a large piece, is the sum of the measurements of the two smaller pieces that make it up. Next, I have a couple questions for you. Pause the video, see if you can answer these questions. Tell me whether each of those arcs are major, minor, and the measure of them. Answers. TQ is 120, so TQ goes from here to here, it's 120. QRT goes along like this. Notice that when they were naming that QRT, they didn't say QRST, they just need one. If you put more than 3 letters down, that is incorrect, but you would like to have 3 letters when describing a major arc. And then to figure out this angle, it's 100 degrees. You just simply take 360 minus 60 minus 120 minus 80, and you'll get 100 for that little arc right there. Number 3, TQR. TQR is a semicircle. You know this because the angle measurements add up to be 180, and it looks pretty straight through there, so you can pretty much assume that it's a diameter. Number 4, QS. Now notice on this one they said QS, and that is a minor arc, but it does go through the point R. So when they do a minor arc, they're doing it with 2 letters, even though it does travel through a third. So it was a minor arc, and they denoted that by only using 2 letters rather than 3. Number 5, TS, minor arc, measurement of 80, pretty easy. And number 6, TSR or RST, is your semicircle with measurement of 180 degrees. Moving on. 3 more problems. Pause the video, see if you can tell me whether those arcs are congruent or not. Also give me a reason as to why or why not. Answers. Congruent, not congruent, congruent. The reason being these lie in the same circle, so thus have the same radius, and they have the same central angle. These are not congruent because although they have the same central angle measurement, they do not lie in the same circle, nor are their circles congruent. And then lastly, we have the same angle measurement, but even though they're not in the same circles, the 2 circles in which they lie are congruent to each other, so the arcs themselves are congruent. Lastly, there is your assignment. I will see you next time.